We're going to focus on matrix multiplication. We have two primary goals: understanding the geometry, quote unquote, and understanding meaning. So one of the most deceiving problems to a lot of people is this one here, where you're taking a 1 by 2, 1 row, 2 columns, times a 2 by 2, 2 rows, 2 columns. Now, keep in mind that the inner dimensions are the same here, so it's okay to multiply them, because whenever you drop the 3, 2 down, there's a 1 and a 2 for the 3 and the 2 to match up with, to multiply together before they get added. So let's think about the resulting matrix. If this is a 1 by 2 times a 2 by 2, then the outer dimensions tell us that the matrix should be a 1 by 2. So that should be 1 row, 2 columns. Okay, well, how do we get the 1 row, 2 columns? Well, we're going to take the first column of, the first column of the second matrix, and we're going to multiply it down on top of the 1 and the 2. So what do we get? Well, for the first row, first column, we're going to get the first row, first column of our new 1 by 2 matrix. Well, that's going to be 3 times 1 plus 2 times 2. So 3 times 1 is 3, 2 times 2 is 4, so that we get a total of 7. Okay, now similarly, to get the next one, the second column that we know we have to have here, we're going to have to take the second column and drop that down on top of the first row of the first matrix. So we're taking the first row of the first matrix, and we're multiplying it by the second column of the second matrix, and I'm just using the colors here to dictate what we're doing. So we get 4 times 1 is 4, plus 2 times 6 is 12, 4 plus 12 is 16. So there we go. Now, there are no additional rows here, so there aren't going to be any additional rows in our matrix over here. If this were a 2 by 2, then this would be a 2 by 2. Next, let's take a look at meaning. So here we have, I've written up a little example, and let's suppose that this example means that we have two banks, Bank 1 and Bank 2. Bank 1 has 15 customer service representatives and 13 managers. Whereas, I think I wanted to switch, no, that's okay. We'll just go with it. Whereas Bank 2 only has 2 customer service reps and 1 manager. We'll say that the customer service pay is $28,000, so we'll say this is in thousand, per year, and the managers make $44,000 per year. Benefits, we'll just say that they get the same amount and they equate to about $3,000. Okay. So, let's say we want to multiply these. Well, why would we want to multiply them this way? Well, notice that if I take the first column of the second matrix and multiply it by the first row of the first matrix, I'm actually lining up 15 and 28 both go with customer service. 13 and 44 both go with managers. So it makes sense that I'd be multiplying those numbers together. Well, this is a 2 by 2. This is a 2 by 2, so what's my resulting matrix? It's going to be a 2 by 2. So that means my first row, first column, I'm going to get from taking 15 times 28 plus 13 times 44. So I'm going to take 15 times 28 plus 13 times 44. And you can use the TID3 to actually multiply these matrices together. That's fine. I'm just showing you kind of the detailed outlay. So it's $992. Well, what does that mean? Well, let's go back and assess the units of what we're talking about. So this is the number of employees, right? So we're taking the number of employees and we're multiplying it by 28. So we're taking number of employees and multiplying it by, well, what is 28? 28 what? Well, it's $28,000 per employee, right? So that's how much each employee gets paid that's of customer service status. And as long as we're multiplying the number of customer service by what they get paid and the number of managers by what they get paid, and then we add those together, guess what our final units are? No, this is not thousand number, this is $1,000. So our final units are going to be thousands of dollars. So that means that for Bank 1, the overall pay is going to be $992,000. The same types of ideas go here, except this is benefits.